понимаю.
Может, человек телефон где-нибудь в другом крыле здания. Что такое разрешено?
Ну, не знаю, это вот это и есть.
Good morning, everyone.
Good morning.
Good morning.
Good morning for somebody. Good afternoon for others.
Welcome to our weekly Friday talks. We are glad to see everyone here. Some of you are already constant guests, some are new, but we are glad that we have more and more with every week. That means that it's interesting.
Yeah, it is true. Well, we may ask our guests in the chat, what countries do they come from? Just to be curious. So if you don't mind, please let us know where do you come from and for whom it is morning and for whom it is afternoon. Maybe for somebody it's already evening.
Okay, I mean, I suppose.
You can also talk to us if you want.
Okay, I'm at my home and this back is my backyard. Okay.
Nice.
Okay, then we hear each other. Is that right?
Yeah.
Okay. The meeting is start already, or we are?
Yeah, the meeting we are just starting. So if you have any questions or comments, or if you want to share something, you can do that. So we have Lithuania. Where do you come from, Dragan?
Dragan came from Serbia, Novi Sad, Serbia. I have my own company, Aquafilter, and doing this job 15 years, established 15 years ago. And I'm interested in most residential water system device, but industrial, this is new for me. Okay, that's why I would like to hear what you're trying to say about errors or something. The biggest one I sell here in Novi Sad is some kind like 4,000 liters per hour. That's the biggest one I sell.
No, this is already in the industrial one. So today we will talk on the startup of the unit. So how to start the water treatment station based on the commercial RO. So we are going to start. So you may switch off your camera. I think it would be much more easier for you and for everyone. So today's topic is how to start water treatment smoothly. And today we will, as usual, I will cover some general information. I will start, and then Oksana, as the head of our customer support, will ask questions that you normally ask Oksana and our colleagues. So you may also ask question in chat. So you can type questions in chat, or you can switch on your camera like Dragan does and ask personally. Do whatever you want to do. So I will start, and I will start with some general idea of the startup. So the startup of the water treatment station is the most important part in the life of every water system. So I can compare it. So if you are an actor in the theater and you have been preparing your play for a week or for a month, and the startup of the water treatment station is the same as the premiere in the theater. So you have to be well prepared, and this is the very important day. So when the customer would get the water in the amount he wants to have and in the quality he wants to have. So we have to understand that when we do the startup, we have to finish this day. We have to finish this day by showing the customer the water he gets and the quality of this water. So if we don't do this, it means that we have not finished the startup procedure. And the good thing that we also understand that you have a lot of work to do on site And I will share some photos with you of what we do during the startup, how we help you to do that. So first, what I have to mention that every commercial reverse osmosis unit with 4-inch membrane is wet tested at our facility. So I think now you can see my screen. Oksana, can you see?
Yes,
Yeah?
Rusty, we can see.
So this is the testing point at our factory. So every unit we drive, I would say we test drive every unit for few hours. We test drive every unit for a few hours at our facility. So basically we do the first startup. So what we do, we put the water under pressure, we put the system under pressure, and we let the system run for at least 3 hours. And during that hours, we check the pipe integrity. So if there are no leakage, no damages, so that everything is connected and installed in the right way. Also, what we do, we check all the automatics. So we check the floats, we check the relays, we check the performance of the controller. And when the system is ready, so when all the tests have been passed, all the tests are complete. So we have the air compressor, and then we just blow out all the air from the system so that you get the dry system to prevent the bacterial growth, and also what is more important, to prevent freezing of the system during the winter time, because in our part of the world, during the winter time, if we don't move the water out, we might have some issues with the pump. And then secondary, when you do the startup, when you prepare to do the startup, we also help you with the videos. So now you see our YouTube channel, and this is one of the videos that explains what you have to do or how you have to prepare yourself before doing the startup. So it is crucial important so that you, and especially your technicians, they read and understand the manual and understand the details on how the system should be started up. So in our manuals that you can easily download on our website, you have both the sequence of the startup procedure, and also you have all the details on how to start the unit, how to program it. Also, you have the troubleshooting. So it is very important to have the manuals and also to go them through. Yeah, I know that somebody of you are the engineers, so you have to do it personally. If you are a managers or a head of technical department, so make sure that your people has read the manuals and know what they do on site. Also, secondary.
Right, when I'm sitting here looking at the computer and I can't hear one more person next to me.
Also, it is important to check
to
check the amount of water that you have on site. So you may use a standard test that is called pressure gauge and bucket test. So if you don't have a flow meter, so you can use just a bucket and a timer just to understand how much water you have, what is the flow on this particular site, and what is the water pressure. I will also come back to the water amount and the water pressure a little later. So this is crucial important to understand how much water you have before the water treatment station. Yeah, then afterwards, when the water quantity is checked, then always check the influent water quality. So we have, I believe you have a variety of tools, simple TDS meters or a kit a set of drop tests for hardness, for iron. So make sure that the water you have in the water analysis, in the water protocol, and the water you have on site is the same water. This is also important before you start the startup. Yeah, you have to check it, and you have to compare the water that is delivered in that very day and what was the water when you do the project and when you did the design. So this is the way. I will skip a little bit. Then of course you do the plump work. So you connect the pipes, the water supply, the drain, and also we will also cover it. You have to install all the cartridges and the membrane inside. So we will talk also later on this in more details. But this is the job that have to be done on site, and you may pay attention at what tools you should have with you in order to do this work. Yeah, we recommend to use gloves when you do the installation. Just prevent bacteriological growth, and then pay attention on the way how we install the membrane. Yeah, what should be the direction of the flow, the direction of the location of the O-ring on the membrane. Yeah, very often we just forget to install a sediment filter. So this is another story that have to be covered. You know, all the filtration medias, all the filtration elements, as well as the membrane, of course, should be in place. This is what is obvious, but very often we forget to do so. And now I will jump to this scheme. We also suggest that every technician, before he goes on site, he has a flow chart of the complete water treatment station, so that he can prepare himself for the startup, and he should understand what the equipment will be installed and what is the flow scheme. For example, in this case, we have the raw water storage, the delivery pump. We have 4 stages of prefiltration. We have the reverse osmosis unit. Then we have the permeate tank and the pump, the delivery pump. And it's very important to mention here that we have the service flow rate, and we have the service flow, and we have the flow rate for the forward flush. And these are there is a big gap between these 2 flow rates. And when you select the pump and when you do the startup, you have to take into consideration that when you do the forward flush of the reverse osmosis, you have to know what would be the flow rate. And also we suggest you to when you adjust the delivery pump, you have to evaluate that every prefiltration step would have a pressure loss. And the pressure loss, we assume that the maximum pressure loss would be around 1 bar at every stage. So for example, this is like the maximum possible option when you have the 4 stages. So it means that if we would like to have 2 bar pressure at the reverse osmosis unit, so the pressure at this point should be 6 bar, because when the media or the cartridge would be blocked or would be with some sediments inside, so then you would lose 4 pressure bar, and for sure you would have the low pressure on the system. Also here in the red circle, we show the vacuum breaker. So this is the check valve which we always recommend to install in between reverse osmosis unit and the pressure tanks, because if in some cases if the RO unit is on and there is lack of water or somebody has closed the valve. To avoid damage of the pressure tanks, we recommend to use this vacuum breaker. So it would be also nice to know what do you use to protect the prefiltration, before how to protect the prefiltration out of damage. You can write. So we have already some questions. Why the carbon filter is placed after the softener? It depends. It depends on the water quality. So we quite often we put the carbon filter in the very end of the prefiltration. For example, in this case, the carbon is installed to remove the chlorine. And when we have a softening, for example, the ion exchange resin also removes some chlorine, because after a while you will have some biofilm on the softening resin. You will have softening resin itself, and some of chlorine would be removed by the softener by just contacting the water with the media. So then when we put the carbon in the very last stage, it means that the carbon would be would have less load on chlorine. So this is the first reason. And another reason, so if you have chlorine on the first and the second stage of prefiltration, we would keep those materials in better hygienic conditions, because if you don't have chlorine, you might have biological growth on the media. And this is the reason why we put carbon in the very end of the prefiltration. So this is basically what I wanted to start, and now we can jump to the questions you have, and the questions from Oksana.
Yeah. Thank you, Rostislav, for the introduction. It was very useful and interesting, by the way, with the last question for me as well. So thank you for the explanation. Yes, we had some question, and basically more question that we received from our customers about the commercial systems is about the installation and post-service. So in generally, the first question is the very basic. What do we need to have with us on the site?
So when we are preparing ourselves to start up the unit, first of all, we need to have documents of this water treatment station. So I always suggest that you provide for the technician, you provide the flow chart. So give them the flow chart, give them the specification of all the equipment that he is going to install tomorrow or next week. Also provide him with information on the water quality that the unit was designed for, and also what are the requirements of the customer, because your technician would be the person who will explain then to the customer how the system is working, and he has to show somehow that there are the water treatment parameters, and this is the water, and the water quality after this unit meet these water quality parameters. This is very important to do this final test before we leave the site. Also, we need to have general tools. Yeah, this is what you have seen already in the video. So these are the basic. This is the basic things. Also, I suggest that every technician should have a TDS meter. So we deal with the reverse osmosis, and we are going to demineralize water. So we have to be sure by ourselves that the TDS has changed. So I would say that I would even say that you must provide a TDS meter to a technician before he goes on site. Of course, the hardness kit, the drop test for hardness, for iron. It's important also to mention that you need to have the food grade glycerin to install the membrane. This is important. Otherwise, you might have issues with the water quality. We will also talk more, and that I believe you would have questions. And maybe you should have some spare parts. Sometimes we have like electricity issues. When you start the unit, you have some power damage of the unit. So at least you should have a fuse for the OS 500 controller, or you should have a controller somewhere at least in your service center, but the best would be to have it in your truck. Some pressure relays. So these are the set of documents and units that you have to have with you.
Okay, that is clear and good. According to your experience and to the experience of our technical department, what are the most popular issues or difficulties that can be appeared during the startup?
So the main issue is the amount of water. So we finished our last Friday talk that there are like four types of issues. So no water, lack of no water, no water and no water. So the reasons for that are different, and now I will explain. And of course there are some other issues. Basically, when you start the RO system, the most common issue that you have on the display, you have the message like dry run, and then you don't know what to do. So this is the typical issue. Sometimes you have issues with lack of water. Sometimes you start the system and it immediately stopped. So these are the typical issues, and then for every case, now we will talk in more details.
Yeah.
And just a moment, we have one more. We have one more question here. Let's answer it immediately. The manufacturer recommends to remove chlorine from the water. Well, it depends actually. It depends on the amount of chlorine you have. Yeah, if you can write the amount of chlorine you are asking about, yeah, in ppm. The general answer to your question would be that if we are talking about the chlorine in the tap water, so we are like 0.5 ppm of chlorine, so then a good and very good cation exchange resin would not suffer from such amount of chlorine. So if you're talking about the good quality resin, not the cheapest one you may find on the market, so then you would not have any issues with 0.5 ppm of chlorine. Of course, if you would buy the cheapest possible resin on the market, which I personally do not recommend to do at all, but if you did so, then you have to protect it out of chlorine. Otherwise, the chlorine could damage the resin. You could have leakage of organic substances from the resin. So in this case, yes. But if you are buying the resin like from DuPont or from Pura resin, so these are good quality resins, and you can easily install them on this type of tap water you have just mentioned. Of course, if you do the chlorination with the few ppm, like 2, 3, or up to 5 ppm of chlorine, of course, in that cases, you have to reduce to remove the chlorine from the water, and then you should go for softening and other stages. I believe it answers your question, and then we can continue with our.
Yeah, we can move forward.
Yeah.
Good. Just Rosti, what is the logic behind the startup? What should we do at the first? What should be done at last?
I would also come back a little bit to the scheme I have already shown. So when we look at the scheme, so our first step would be to start with the equipment where the water just flow in. So for sure we should start with the storage tank, with the pump, and we have to do the startup, in this case from right to left. So we do the water supply unit. Then we have to start up stage by stage the prefiltration. As soon as the prefiltration is done and we have checked the water quality after prefiltration, then we go to startup of the reverse osmosis unit. When it is done, then we set and adjust the water delivery. And the final stage of every startup is to check water quality, check water quantity, invite customer, and show him how good you are and how good is the equipment. So this is the general logic of the whole process.
Okay, and do not hide the schema.
Okay.
Yeah,
Okay.
when we are talking about the prefiltration, what are the key points to start the prefiltration in according to the Aero system?
Yeah, now we go a little bit away from the reverse osmosis, but it's important to explain this. So, for example, here we have the sediment filter, we have a softener, we have a carbon filter. So we have to start up every unit in sequence. For example, in the sediment filter, we use the filter egg or filter egg media. So it means that we have to, first of all, we have to load the media in the tank. So there are also some technical secrets on how we recommend to load it. So never load any media in the dry tank. You should always put 20-30% of, you should fill the tank with 20 to 30% of volume with water, just with normal raw water. And when you load the media, load it on the water, because in this case, you prevent additional formation of powder and additional formation of small parts. So when you loaded the media, you may fill the tank manually, just from the hose, like half of it, or even up to 70%. And just let the media, especially the filtration media, let it soak for at least 4 hours, because when the media is completely wet, then you would need only one backwash and one rinse to remove all the dust from the activated carbon and all the dust from the filter egg media, for example. And of course, this is also helps to start the softening resin and the EcoMix. So this is the very basic rule. And then when you finish with that, you should do the regeneration of this of the prefiltration stage and do the water test. So you can do a very basic water test, like take a bottle of water, then a clear white clear bottle of water, just pour it with water and just look that it's clear, so there is no parts of activated carbon, because you have to be sure that you would not damage the reverse osmosis membrane. Of course, the best would be to check the hardness. Yeah, if you have the softening, you have to check the hardness. If you use EcoMix media, check both hardness and iron, so to make sure that you do not have any iron delivered to the reverse osmosis unit. So these are basically the points that have to be made during the startup of the prefiltration.
Okay, thanks. This is what about prefiltration, but what about the Aero? What should we pay attention to when start the Aero?
We have also some, I'm sorry, I will jump to some comments from Rick. So there are recommendations. So this is also a very sophisticated answer to the previous question of the resistance of the cation exchange resin from chlorine. Rick, thank you. I think this is also maybe very useful for everyone to just to copy it and to know what is the what are the guidelines. Thank you. It's very useful, I think, both for us and for guests. Sorry, Oksana, now we can come back to your questions again.
Should I repeat it?
Yes, please.
Yes, of course. You told us what we should pay attention to with the prefiltration, but how we should start the reverse osmosis system itself?
Yeah, the reverse osmosis system. So I will start with a smoke joke. Before we start the reverse osmosis unit, we have to install a membrane. This sounds very basic and sounds like a joke from my side, but we have so many contacts and so many requests to technical support, and I would say we have often the case when you start the complete system and then you read the dry run alarm on the screen, and then you call us and says, I have a very good pump, I have checked the prefiltration, everything is perfect, but there is dry run and I cannot start the unit. And when we start asking questions and just to investigate what are the reasons, finally we come to a situation when the membrane is just standing somewhere in the corner of the room, but not in the pressure vessel. So in this case, you have a lot of water. So the high pressure pump of the RO, it pumps water with low pressure. And then of course you would have a dry run because you would not have enough water on the prefiltration. And this is what we should pay attention to.
Mm-hmm.
Yeah, first install a membrane. So then we have to push out the air from the system. It is especially important when you have a system with 4 and 6 membranes, because you have quite a space there, quite an empty space there. And I will also jump right now to another document, I would jump to the manual. So this is the manual that you can download download at our website. And what we recommend here, so when you do the startup, you can enter the menu, and there is a at 1.1. So this is the second step of the setting. You can change the high pressure pump delay. So what it means, when you start up the unit, by default we have 10-second delay. It means that first the solenoid valve is opened, then the controller waits for 10 seconds, and then it starts the pump. So here we have a footnote that says that when you before start the system, change it to 255 seconds to push out the air from the system. Then you wait. Maybe you have to do it twice. Just make sure that there is no air inside. And when you do this, then you can do the startup. You can do the startup sequence. Start the unit, adjust it in the right way, and so this is basically all you have to do during the startup.
Okay. While you were talking about the membrane, is there any recommendation or rules how to install correctly the membrane?
Yeah, there is a basic rule. There is a basic rule that the membrane has the O-ring. I believe you have paid attention when I showed the video in the very beginning. The membrane has one O-ring from only one side of the membrane element. So the O-ring should be installed, should be located at the place where the raw water enters the pressure vessel. So this is important thing. Also, make sure that the O-ring is not damaged during the loading of the membrane. So for this reason, we recommend to use the food grade glycerin. You just lubricate the O-ring with this glycerin, and then the procedure would be very smooth and without damage of the O-ring. So this is the way we recommend to do. Of course, on the video we have shown that we recommend the technicians to wear gloves and to avoid avoid additional contamination of the membrane when you put it in the pressure vessel. So you can, again, you can show you and your colleagues may advise all technicians to look through this video for some very minor tips, but they are very important. Just look through this video, and then your technicians would know all the details that you have to take into account.
Great. Thank you for your answer. One of the most popular questions that we receive in our customer service team is the dry run alarm from the system. So that means the low pressure alarm. What can be the reason of this mistake?
Yeah, first, this is the pressure loss. The first reason for the dry run is the pressure loss on the prefiltration. So when you start the unit, you have to adjust the power supply tank, the power supply pump. This is what should be done during the startup. And then make sure that you have removed all air from the system, both from the prefiltration, from the reverse osmosis unit. So before you do the startup, yeah, perform the regeneration of the tanks, perform the right filling of the reverse osmosis unit. So this also will minimize the possibility of the dry run. Also, another thing is the reverse osmosis membrane. So when you do the start and the membrane is fresh, for example, if we take the XLE 4040, it would provide you in some cases up to 400 liters per hour. And then when you design the prefiltration, maybe you took into consideration less amount of water. So when you would start adjusting the recycle, when you start adjusting the drain, so you can decrease the operating pressure. So you can just open the recycle valve on the pressure on the reverse osmosis unit, decrease the pressure, then the amount of permeate would also go down to the designed level, to 250 to 300 liters per hour. It means that also you will decrease the consumption of water, and then your pressure drop will be less. So this is also a possible way to do that. Another thing, you could also adjust the pressure relays. So our default settings of the low pressure relay is 2 bar. So if you see that you have 1.8, 1.5, so you can also adjust the pressure relay up to you so that the system operates smoothly. So these are the tips that should be taken into account when you fight with the dry run. But of course you may fail, yeah, this fight. And this is also a good question, what to do if you cannot fight with the dry run. Then our technical support also adjusts to have an additional the permeate flushing kit, the PIMO kit, to have it with you, so that if you have a lack of water during the forward flushing, you could do the forward flushing with the permeate, and this would decrease also the amount of water that need to be delivered. But this is also another topic which we could jump in if there would be more questions from colleagues. Oksana, we can also look at the chart.
Yes, please.
Are bacteria a problem for a raw membrane? And if so, how we can clean the membrane from bacteria? Yeah, the first step is not to put additional bacteria to the RO. So this is the first step. So both during the startup, so we have to do it in more or less clean environment. Also, you have to be sure that the water that you use as a raw water is either free of bacteria, or you have to do the disinfection before RO. I don't know what if you have any particular question, or because in generally, yeah, this would be the answer. Yeah, do the disinfection, prevent prevent contamination during startup, and also if you have already bacteria on the membrane, you can do the CIP. And when you do the CIP, you should introduce the biocide in the CIP cycle. There is a question also from Anton. The system requires at least 2 bar. What if we overpump? Yeah, the system, the 2 bar is a very good, by the way, very good question from Anton. If so, the 2 bar is the minimum. So the 4 bar is the maximum pressure, and there would be, so if the pressure would be higher, it means that you would have more permeate. So the higher the inlet pressure, the higher would be the operating pressure. So the more permeate you would have. So if you have more than 4 bar, then it would mean that probably you would have too much permeate, and your prefiltration is not designed for that. So in this case, you should somehow cut the pressure before the RO unit. Or you could, when the raw water pressure is high, you can also adjust the operating pressure by opening the recycle valve. Yeah, so open it to the maximum, and then the operating pressure will go down. There is also a question from Tom. Bacteria will grow in permeate tank eventually if there is no UV or something. So I believe this is a question. So I take it, I consider it as a question. So yes, in the permeate tank, eventually you would have some bacteriological growth. It is true, and in this case, we suggest to do certain steps. So first, when you select the permeate tank, you should select it with the material that do not allow sunlight to go through. So the polyethylene is not the best option, because polyethylene is transferable for the sunlight. So if you have the sunlight, you will have growth of bacteria. Also, you have to select, and you have to pay attention on the surface of the tank. So when you go for the polypropylene tanks, so the surface of the polypropylene tanks is very smooth, and it's not a good surface for bacteria to grow. So these tanks would be less likely for the microbiological growth. Also, we suggest to do the cleaning of the tanks. So when you do the design of the water treatment station, you have to think about how you would clean the tank. Would you have access to it? Very often we do it with the car wash station. Yeah, with a small car wash station. You just bring it on site, open the tank, wash it. You may also wash it with some chemicals like the basic chlorine or with household bleach. And of course, we always recommend to install a UV lamp just after UV. Yeah, you have to know the flow rate and select the right UV lamp just after the tank, and it is very effective because the water after reverse osmosis is very transparent, so it is clear, and the UV disinfection is very effective, because the effectiveness increasing with the transparency of the water. So if you do these precautions, or if you do these steps, you would not have issues with the bacteria growth afterwards. Now we can come back to our
Yes, I will.
Questions and answers.
Great, thank you. Together with this dry run, another popular issue is the immediate stop after the system starts. So just, can you please explain why this can happen?
Yeah, this is so when we finished the startup of the RO, and we press the button start, we do not have dry run, but we have immediately stop, and the unit goes to standby. with no water production. So from time to time it happens. I will again go back to, I will go back to the, I will go back to this diagram. So now you can see this flow chart.
Yes, we do.
So when you have start and immediate stop, there could be two reasons for that. The first reason that when you put the float in the tank, you disconnect it from the power from the power box, but you didn't connect it back. So I show right now the image so that everyone understood. So in the power box or electrical panel of the reverse osmosis, there are contacts for the float switch. So you could see the 7 and number 7 and number 8. So normally when you do the installation of the float, you disconnect it and then you just forget to connect it. If you mismatch this black and blue, nothing wrong would happen, but you have to connect it back. So this is the basic. This is the basic reason, but there is not only basic one. So there is also every reverse osmosis unit is equipped with a permeate pressure relay. And when this pipe, the permeate pipe that connects the unit with the tank, is very long and has a small diameter, you may have a pressure increase during the start of the unit because the water fills the pipe. And when it's not enough, but when the flow is much higher than the pump can let go through, then this pressure relay feels that something is closed here and will stop the unit. And in this case, you have either to adjust the pressure relay, just increase the pressure, or you have to increase the diameter of this line. Very often it happens when the tank is on the next floor. In some applications, when you are limited with space, you put it either on the next floor above, or you put it on some height, and the water after a row is going up. So in this case, you have to make sure that the pipe has enough large diameter to just let water go through. Very often somebody put a valve, just a manual ball valve on the permeate line, and then during the startup just forgot to open it, and then you would have immediate stop. So these are the reasons why you may have start and stop, and this is where you have to look at.
Okay, great. Now my question will be related to the flow rate. Sometimes when we start the system, we can have either low permeate flow or high permeate flow. So something that we does not expect. What can be the reason?
So first, let's talk about the low flow rate. So if you have low flow rate, so first make sure that you have pushed out all the air from the system. So if there is still some air in the system, you would have low flow. So you have just to wait. You have to look at the permeate flow meter. Just look at and check if there is no water bubbles there. So then. The low flow rate could be the reason for the low flow rate could be the TDS of the raw water. Sometimes we have these cases when you design the system, you looked at the water test and the TDS was 500 ppm, and when you're doing the startup, you didn't check it, and then you have a low flow rate. Always check the TDS, because it could be much higher. It could be 1500, and then of course you would have less water at 1500 TDS than 500 that you designed. Also pay attention to the water temperature. So now it is spring, the water is becoming warmer, but if you do the startup during the winter time and the water supply pipes are close to the surface, and the water could be 5 or 6 Celsius degrees, then in this case you would have a dramatic decrease of the flow. So pay attention to these parameters. And other side, if the flow rate is too high, then from one side it's good. We have a lot of flow rate. So first,
But
when
we
you
always have but.
but there are some buts. Always when you have a high flow rate, always check the TDS. So most probably you have just a leakage somewhere. Again, you can have a leakage on the O-rings. If you have 6 membranes, you may forget to install one of 6 membranes. So this is, well, sounds very silly, but well, it happens. So check the TDS. So if the TDS is very high, it means that you have leakage. Yeah, if the TDS is okay, but you still have a high flow rate, it means that the water on site can be a better quality than you expected, and that water temperature could be higher. For example, we have cases when the water treatment station is installed in the boiler house. You have quite a high capacity boilers nearby, and the environment is quite hot. So the water temperature could be 20-25 Celsius. That is not normal for our area, but you would have much more water than you expected. So these are the reasons that you have to pay attention at.
Okay, great. And the last question in my list. So after a RO starts up, we could have poor quality of the permeate. What can be the reason of that?
The poor water of the permeate could be the temperature of the water. So this could be one of the reasons. So if the water is very warm and the requirements are very high, for example, you do the water treatment for some chemical production where they request a TDS maybe 5 ppm and or 10 ppm, but when the water temperature is going up, then we should all know that the higher the temperature, the more salts pass through the membrane. So always look at the temperature. Then another thing, if the raw water TDS is much higher than we expected, so you would also have influence on the TDS of the permeate. Yeah, if we calculate it on 500 or took into consideration when we made the design that there would be 500 ppm, and in fact you have much more, then you have the problem with the pure quality of the permeate. And of course, it might be also some leakage. So what we suggest to do, if you have the issue with the poor quality, please collect the information that you have. So the temperature, the TDS of the raw water, make a photo of the settings and send it to our technical support. Then we will do the calculation, and then we will come back to you with the reply. Because sometimes sometimes you had one expectation and you get another result, or we will tell you, so this is the leakage. But collect information and we will help you to understand what is the reason. There is a question from Dragan. We often auto installation for the software before our system. What we have to do if we're all broken because of salt? By broken, I mean that it does not soften water because of salt. This is what I understand. Yeah, this is what we have. This is what we have to consider. So when you have a softener before a RO, let me read the question again. Well, a RO membrane cannot actually be broken by the salt. So the membrane can be blocked by salt. So if you have a high amount of salt before a RO membrane, then you would have issues with a low amount of water. So the salt actually decreases flow rate. And if you design the system in the wrong way, so you would have a buildup of salt on the membrane surface, and you would finally get less water. But the quality of that water would be more or less the same. Yeah, it would also be slightly coarser, but you would have a significant decrease of the flow rate. The membrane can be broken, or I would say can be damaged, if you have chlorine in the water. So when you have the chlorine in the tap water and you do not remove the chlorine, so this is what makes the membrane broken, and you would see it, you would have more water, but the water quality would be significantly lower because the membrane makes, I would explain it in a simple way, the chlorine just damaged the membrane surface and the pores of the membrane become larger. So it becomes much more easier both for water molecules and for the salt to pass through. So when the membrane is broken with chlorine, you would have more water and more salt in that water. But if your softener is not operating good, then you would finally come to a situation when the membrane would just stop producing water, and your customer would call you and tell you, Dragan, I don't have water at all after your RO. I hope that my answer provides.
But we can clean such membrane. Is it correct, Rosti?
Yeah, we can clean if we catch the right moment. So if the membrane flow rate decreased by, as we discussed last time, by 15%, then almost, I would say 99% that we would clean this membrane up to initial parameters. If we didn't catch the right moment and we have and the decrease of the flow is 30% and more, then I would also clean such a membrane, and I would see what would be the outcome. Most probably you would also restore the membrane, but not to initial parameters.
Okay, thank you. Dragan, thank you for the question. There
is already 1 hour. We are online. So thank you for your questions. Thank you for your time. I think next week is a Friday before Easter in Europe.
Yes, in Europe, yes.
So I think instead of talking about arroz, we would be talking about painting eggs, eating chocolate rabbits, and baking cakes. So I think next week we will make a pause in our talk. If you have any questions right now, please feel free to put it in the chat. If no, you may always send us emails. So we get emails more and more. Thank you for your
active participation. Yes.
Yeah, thank you also for your emails, for your questions that you do online and you do in the email. You always feel free to ask. Thank you, Oksana, also for your questions.
Yeah, and I would also ask you to think maybe about what else regarding this topic you want to hear from us. Because sometimes we have the one point of view, you want us to cover some other questions. So please send us the messages to me or to Rosti, and we will provide the proper talks next time.
Yes. So have a nice Friday. Yeah, it is possible. So this is the answer to Lukas. All the videos like next week, they will be downloaded to our YouTube channel, and also I think everyone who register would get a link. So you would next week, like next Monday or Tuesday, you would have an email so that you can download or just look through the video. This is what we do regularly next week. So bye. Have a nice
Thank you, everyone.
weekend.
Have a nice
Thank
Friday.
You. Yeah.
Bye.
See you. See you.
Bye-bye.
Bye.